I'm Kathy Benison. I'm an Associate Professor of Geology at West Virginia University. This is a gypsum crystal that I collected from an acid saline lake in Western Australia. As this gypsum crystal grew, it also trapped tiny bits of the lake water from which it was growing in microscopic droplets called fluid inclusions. Sometimes those fluid inclusions also contain bits of air. So this gypsum crystal contains bits of lake water and air from Western Australia. Microorganisms such as bacteria and algae that are living in the lake water, that was the parent for this crystal, those microorganisms also can get trapped in the fluid inclusions in this crystal. And sometimes those microorganisms remain living even though they're trapped in a mineral like this. So this is a sample of halite that also comes from an acid salt lake in Western Australia. And halite's very much like the gypsum. It grows quickly and it traps bits of lithosphere, hydrosphere, atmosphere, and even biosphere in its fluid inclusions. These samples here in my lab now in Morgantown tell me a lot about the environment in which they formed in Western Australia a few years ago. So from this halite sample, I can tell you that 260 million years ago, Kansas had lakes that were really extremely nasty. They were rich in dissolved iron and aluminum and even arsenic. They had a pH that went down to 0. I can also tell you that it was very windy there with a lot of red dust blowing around, and the air temperature went up to 74 degrees Celsius. That's about 156 degrees Fahrenheit. So these were extreme environments, and I know all that based upon studying the fluid inclusions in this ancient halite. I think the best place to look for life on Mars is in fluid inclusions in halite and gypsum. Exciting geology data coming back from Mars shows that there's a lot of similarities between rocks on Mars and these acid saline deposits that we see on Earth in places like Western Australia. So that leads us to believe that Mars likely had acid salt lakes like we see on Earth. And on Earth, the deposits formed in them, the halite and gypsum, trap microorganisms really well. So perhaps the best place to look for life on Mars is in halite and gypsum there. These fluid inclusions really are little time capsules for Earth history.